Okay, so one important point to note here is when we were talking about NMS, even though we are trying to suppress the nearby or overlapping bounding boxes, but again, as I said, that was part of the algorithm. Your algorithm might not be using NMS at all. Okay, so once your network has said, okay, these are the bounding boxes I have predicted, so you might still get like these kind of overlapping bounding boxes. Then the idea is, if you have two bounding boxes actually matching to the ground truth, where the class label is also correct and the intersection over union is also greater than the threshold, which is 0.5, but still only one of the bounding boxes will be counted as true positive. The other will have to go to false negative. And the reason is, ideally, essentially what I can do is I can just draw like bounding boxes all over this image and say that it's a person, it's a person, it's a person. And for sure, like I will be able to catch all these individuals here. But again, that's not like a right algorithm, right? It's giving a lot of false negatives. So that's why we need to make sure only one of the prediction is actually matched against the ground truth. Once you have matched the ground truth, that ground truth is actually out of picture. Then for future predictions, you will not have access to it and it will be counted as false negative. Now, the precision and recall, the definition remains the same. It's not going to change. It's just like how you are computing your true positives and false positives. Okay, precision, is like a ratio between your true positives and you add like true positives and false positives. And recall is, again, you have true positives, but in the denominator, you have true positives and false negatives. And the concept remains the same. As I said, precision is how accurate your model is. Okay, if your model is saying there are 100 cats in this image, then out of those 100 predictions, how many predictions are actually correct? It doesn't matter if the algorithm actually missed thousands of other cats. So there might be like 1,000 cats in your image, okay, but your network only said like there are 100 cats, and if all those 100 predictions were correct, your precision is 100%. Okay, so precision will have value of 1. So precision is just computing how accurate your model is. It's not looking into the coverage. To look into the coverage, we have recall. So the idea of recall is, if you had 1,000 different cats, how many of those cats your model was able to predict? Okay, so for example, if you had 1,000 different cats and your model said like 100 different cats and all of those were correct, the recall will be only 10%. It will be 100 over 1,000. So in this particular scenario, your precision is 1, but your recall is 0.1. And that's why both precision and recall are important. You not only want to detect your objects correctly, you also want to detect all the possible objects. And a good example to think about this is, as I said in the previous slide, potentially what you can do is you can actually place the bounding box in all the possible locations in your image. Right. So in that case, you might have a very high recall because you will be able to detect like all the individuals there, right? But again, the precision will be very bad because a lot of those will be wrong predictions.